Hi, this is my math lesson for fractions. I apologize for the writing. I tried recording this already once and it deleted on me. So, this is my second run of doing it. Okay, first thing we do is go over and cut out the pieces that we're going to be using today. Be cutting out a whole piece, eighth pieces, quarter pieces, and half pieces. Now what I'll do first is have the students pin up each of the 1/8 pieces and asking them how many eighth pieces fit inside of a hole. So they'll lay them all out on their own pie chart and find out that there are 8 that fit on one whole piece. Now they'll do the same for the quarter inch, or sorry, the quarter. They'll go through and lay out all 4 of theirs on there. Sorry, I have a couple on the ground. And then do the same with the half. And they'll find that there's 2. Now I discussed the relationship between the that it takes 2 pieces. For the denominator, there's 2 parts to a whole. And for the quarter, there are 4 parts to the whole. And this is only 1 part of the whole. So by saying that I have 1/4, I'm saying I have 1 of 4 parts to the whole. So we go over that. And when they start to grasp that concept of parts to a whole, we go and we start doing a little bit of addition. Now for the first one, we keep it very simple. We have 1/8 plus 1/8, equals what? So as a class, we're going to go over this, and I'm going to grab my Sharpie, sorry. We have 1/8, and again, sorry, I already wrote on this. I already wrote this all out. But we have 1/8, so 1/8 plus 1/8 equals 2/8. And the way that works is the denominator will stay the same because we have the same denominator. Both denominators are 8, so we can keep the denominator the same. The denominator is the bottom number. Now the numerator, the top number, we add straight across. So 1 plus 1 equals 2. So we have 2/8. And down here, we have 2/8, or 2 pieces, 2 of 8 of a whole. So 2/8. However, 2/8 can be reduced down. By reducing, we mean that we bring down the top number as low as we possibly can fit inside what it is. So we have 2/8. Now, we know it can't be half, because the half doesn't quite fit. So, but a quarter does fit. And again, they'll be doing this along with me as we go. I'd probably have them go through and try and figure out which piece fits. So, the quarter piece fits. So by doing that, we have reduced it down, because 2/8 equal 1/4. Now, for 2/4, we have 1/4 plus 1/4. What do we have? And again, have them use the pieces, we'd have a half. Now those work because the denominator is the same. They are the same parts. So 1/4 plus 1/4 will equal 1/2. 1/8 plus 1/8 equals 1/4. And 1/2 plus 1/2 equals 2 halves, or 2/2, but it also equals 1, because that is 2 parts of 2. There's only 2 parts of 2 equaling a whole. Because if you have 2 parts and you have both parts, it equals a whole. Now, for the tricky stuff. If we have 1/4 plus 1/8, what do we have? Now this is where it gets a little complicated. I'm going to rewrite this because it's kind of hard to see. If we have 1/4, now obviously I'd write this bigger for them to see, I just don't have a lot of room, plus 1/8, we notice that our denominators are not the same. Now we need to change that so they're the same. Now we can't make 1/8 any smaller. That's the smallest piece we have, is 1/8. But I think we can make the 1/4 smaller. So we learned earlier, 1/8 plus 1/8 equals 1/4. Sorry, that's supposed to be 1/8. So now we have 3 1/8s, which if we added 1/8 plus 1/8 plus 1/8, since we have the same denominator, we just add straight across on the top and keep the denominator of 8. So we'd have 1 plus 1 plus 1 equals 3, and the 8 stays the same. So 3/8. 3/8. Now, how do we do that? Writing it out. Sorry, I gotta refresh my computer so it doesn't cancel out on me. So we have 1/4 plus 1/8. So we need to make one of these two the same as the other. Now we can't go any smaller with our 1/8. We figured that out over here. But we did find out that we can do smaller pieces with our quarter. So, what do we need to do to 4 to make it 8? And obviously it'd be times 2. So we'd multiply it by 2. Now whatever we do to the bottom, we have to do to the top. So we also have to multiply the 1 by 2. Because we don't have 1/8 here, we have 2/8. So we have to multiply it by 2, the same as the bottom denominator. So now we have 2/8 plus 1/8. Now we know that the 8s, I try and keep it straight for them so that way it's easier to add across. So 2 plus 1 equals 3, and we keep our denominator the same. So we have 3/8. Now, let's say we have a quarter plus a half. So our new problem is 1/4 plus 1/2. Now obviously we can't add them up because the denominator is the same, or is not the same, excuse me. So we need to make the denominator the same. Now what did we do to the quarter up here to make it the same? We split it up. Now, as you'll see, 2 1/4, as we learned earlier, equals 1/2. So now we have an easier problem. 1/4 plus 1/4 plus 1/4 equals 3/4, because 1 plus 1 plus 1 equals 3, and we keep the denominator, the 4, the same. Now again, we got to figure out what we're going to do up here. So 1/4 plus 1/2, we can't do that. We need to have the same denominator, the bottom number again. So we need to do something to the 2 to make it 4. And from what we learned last time, multiplying by 2 worked. So multiplying by 2 gives us 4. Now we have to do the same to the top. So we'd have 2/4. 2 parts out of 4 of a whole. If you're doing a collection of, stamps, and there's 4 of them that are in that particular collection, and you have 2 of them, you have half of them. Half of the stamps that you need to make a whole collection of stamps. So we have 2 out of 4, which is also equal to 1/2. But now our problem is 1/4 plus 2/4, or 1/4 plus 2/4. So then, again, we can add straight across the top. That's 3. And then we keep our denominator the same. So we have 3/4. Now, if we add 1/2 to 1/8, this creates an even weirder situation, because we've been just multiplying by 2. I don't think that's going to work this time. Because we have 1/8 plus 1/2. So first we need to find a common denominator. Common meaning both these bottom numbers have to be the same for us to add them. So we know that we can't make 1/8 smaller. Well, we can, but for this particular problem, we can't make 1/8 smaller. We could go down to 2/16 if we were doing a different problem, but for this problem, we cannot make it smaller because we need the half to be smaller. So 1/8 plus 1/2. Well, we can't use quarters, because if we use quarters, they are not going to be the they're not going to be the same common denominator. Because if I have 2/4, that'd be 2/4. Those numbers don't match. But if we use 8s, now those numbers match for us again. So we need to find out how many 8s are in that half. Let's go ahead and figure that out, how many 8s are in that half. We found that 4/8 are in 1/2. Again, if you had 4 parts, or 4 stamps out of a collection that has 8 in them, you'd have half the stamps that you need. So, now that we have 4/8, we figured out that. Now to figure it out, writing it out ways. What do we need to do to the 2 to make it 8? We need to multiply it by 4. And whatever we have to do to the bottom, we have to also do to the top. So we have 4 over 8, which is the same as we got here, so we're right. So we have 1/8 now plus 4/8. What do we have there now? We add straight across the top. So 1 plus 4 equals 5. And then what do we do with the denominator? We keep it the same. So we have 5/8. Let's check with our pi. Make sure that we're right. 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. So 1 plus 1, 2, plus 1, 3, plus 1, 4, plus 1, 5. And we keep the denominator the same, so 5/8. Now I'd have the students work in groups, or not in groups, and on their own, figuring out different problems that I put up on the board, more intense ones, and then walk around and help them out. Sorry, this one was a little bit longer than it was supposed to be.